Welcome to RCC's Math Tape Series. In today's tape, you will learn to deal with integers as exponents. As you go through the tape, I want you to make sure that you do three things. First of all, take careful notes. Take notes just as if you were in class. 2, if you do not understand anything, either rewind the tape and listen to the explanations again, or get someone to help you. In other words, if the tapes are going to work for you, you must make sure that you understand every step. And 3, you need to make a study sheet. As I go through the tape, I will star several concepts. For every starred concept, you need to make a study note. You need to write the concept on a separate study sheet and keep the sheet away from your notes and so forth. Once you have a sheet for a complete unit, I suggest that you have it laminated and saved for as long as you're taking mathematics. We will start today's lesson with a definition with which you should be familiar. An expression of the form x to the a is called a power. So you have a letter or number with a superscript. This thing is called a power, having base x is the base, and exponent a. A is called the exponent. If a is a positive integer, then it tells the number of times to use x as a factor. So if a is a positive integer, then it tells the number of times to use x as a factor. Let's look at a couple examples. Let's look at x to the 4th. The base is x, the exponent is 4. The exponent 4 tells me the number of times to use the base x as a factor. So I should use x as a factor 4 times. 1, 2, 3, 4 times. So x to the 4th is x times x times x times x. Now in the next example, we have 2 to the 5th. The base is 2, the exponent is 5. The exponent 5 tells me to use the base 2 as a factor 5 times. So I'll write down 2 as a factor 5 times. 1, 2, 3, 4, 5. Now since we have a numerical base, I can perform the multiplication to get an answer. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So the answer is 32. Now I'm going to give you a sequence of powers that should help you understand the definition of an integral exponent that you will get in the next frame. Let's start with 10 cubed. For 10 cubed, the base is 10, the exponent is 3. 10 cubed is 10 times 10 times 10. Exponent 3 tells me to use the base as a factor 3 times. If I multiply, I get 1,000. 10 times 10 is 100. 100 times 10 is 1,000. Now let's look at 10 squared. 10 squared then would be 10 times 10. Exponent 2 tells me to use the base as a factor 2 times. 10 times 10 is 100. Now with 10 to the 1st, exponent 1 tells me to use the base as a factor 1 time. So 10 to the 1st power is simply 10. Now notice, as my exponents decrease, 3, 2, 1, I divide the answer each time by 10. 1,000 divided by 10 is 100. So my exponent decreased from 3 to 2 to get from the answer for 10 cubed to the answer for 10 squared. I divided by 10. 1,000 divided by 10 is 100. Now if I divide it by 10 again, 100 divided by 10 is 10. Now if I go down to exponent 0, then I would need to divide by 10 again. 10 divided by 10 is 1. 10 divided by 10 is 1. So 10 to the 0th power is 1. Now if I go down to a negative 1, that means I would have decreased my exponent again. So if I go down to a negative 1, then I'll have to divide by 10. 1 divided by 10 is 1/10. If I go down to negative 2, I would have divided by 10 again. I would have decreased my exponent by 1. So if I decrease my exponent by 1, I would divide by 10. So 1/10 divided by 10 is 1 over 10 squared. In other words, I divided by 9 to the power of 10. And 1 over 10 squared would be 1 over 100. 10 to the negative 3 means I would divide by 10 again. So I'd have 1 over 10 cubed. 1 over 10 cubed is 1 over 1,000. So as my exponents decreased, 3, 2, 1, 0, negative 1, negative 2, negative 3, it appears that my answers were divided by 10. 1,000 divided by 10 is 100. 100 divided by 10 is 10. 10 divided by 10 is 1. 1 divided by 10 is 1/10. 1/10 divided by 10 is 1/100th. 1/100 divided by 10 is 1/1000th. But now notice this. If that's true, then 10 to the negative 1 power is 1 over 10 to the positive 1. 10 to the negative 2 is 1 over 10 to the positive 2. 10 to the negative 3 is 1 over 10 to the positive 3. Well, with that in mind, I'm now going to give you the definition for a positive integer, or for an integral exponent. I'm going to give you the definition for an integral exponent. I can't get all parts of the definition on the screen at one time, so you're going to have to take notes and then look back. Let's let x be a non-zero rational number. Now the base could be any non-zero rational number. That means it could be any fraction. So the base can be a fraction. And let's let that fraction be raised to a positive integer a. Now if a is a positive integer, then x to the a is just x times x times x and so forth out to x, where I use x as a factor a times. This is exactly the same thing I gave you earlier for a positive exponent. Now if a is an integer, then it's either a positive integer, it's 0, or it is a negative integer. If it's a positive integer, we have this definition. If it's 0, then x to the 0 power is 1. Now that would be for x not 0. See, x is a non-zero number. So any non-zero number raised to the 0th power is 1. Anything raised to the 0th power is 1. Now how do I deal with a negative exponent? A negative integral exponent. X to the negative a is defined to be 1 over x to the positive a, just as it happened in the sequence with 10. X to the negative a is 1 over x to the positive a, which is the same as 1 over x to the a. So if you have a negative exponent, it tells you to take the reciprocal of the base. Negative exponent tells you to take the reciprocal of the base. Let's give a note in case you have a fraction form.